So this is the intermolecular forces lab, where we took 5 liquids and we performed 5 tests on them to test their different properties and intermolecular forces. Now, the first test that we performed was the solubility test, where we tested the solubility with each other. So the liquids were poured into each other, and we saw if they mixed or not. Now, that's seen right here, and we would pour, and then down here in the data table, we recorded our data, see which ones did or did not mix. Now, I'm not going to go through the data one by one because that's quite boring, but as you can see, water did not mix with oil, and it did not mix with hexane, and that's because like dissolves like, and water is a polar molecule, whereas oil is a non-polar molecule. So the two do not mix, and that's why the oil sits on top of the water. The next test that we performed was the second solubility test. In this, we put 2 solids into a test tube of the liquid, as seen right here. The first one was a salt, so an ionic salt, so it was potassium iodide, and the second, and the second one was sugar. Now, with these tests, we placed the sugars and the salts into the liquids and stirred it around a little bit to see if they did, in fact, dissolve. Now, water was the only one substance that dissolved both of the sugar and the salt, and then hexane did dissolve the sugar. Other than that, all the other liquids did not dissolve the solids. Next test that we performed was surface tension, where you can see right here is we took a penny and we dropped drops of each liquid onto the penny to see how many drops it could actually hold before it spilled over. And this was to test to see how much the molecules hold together. As you can see down here, water had the highest surface tension, with 40 drops until it fell apart. Second, with hexane. The other 3, oil, acetone, and rubbing alcohol, were quite low, and they fell apart quite easily. Next test was the capillary action, where we took a little glass tube that was very, very thin in diameter, and we placed it into a beaker or a test tube of the substance. And then the liquid would suck up into the tube a certain amount, which is seen right here magnified, that the liquid is slowly creeping up the tube. Now, we measured this, but with a ruler in centimeters, and once again, water had the most amount of liquid inside the tube, and that is due to water's polarity, because it is such a polar substance that the molecules bind together. And it's seen not so much in hexane, which is a non-polar molecule, so the intermolecular forces are not as strong as in water. Lastly, we tested for volatility, or in other words, how willing a substance is to evaporate. What we did was we placed a piece of tin foil over the Bunsen burner, or over the hot plate, and then we heated up. we placed a couple drops of each substance onto the aluminum foil, and we turned on the hot plate. And then we took a timer and we gave a limit of 4 minutes to see how fast the substance was evaporate. Hexane was the quickest, evaporating after only 17 seconds, and oil took the longest, meaning that it wasn't even finished evaporating yet when we finished the test. Lastly, the test that not exactly a test that we performed, but something that we looked up, was the boiling point of each substance in degrees Celsius. Water is the obvious one. Everybody knows that it's 100 degrees Celsius. Acetone was 56 degrees Celsius. Oil was, we couldn't find that because it was not specified what type of oil was used. There's many types of oil. There's vegetable oil, there's olive oil, there's baby oil. and they all don't exactly have the same boiling point, so that was just left blank. And then rubbing alcohol is 82.5 degrees Celsius, and hexane is 68 degrees Celsius.
Lastly, a suggestion for improvement could have been that during the surface tension tests that we didn't use drops, but rather specified amounts of the liquid every time, because drops are not always the same amount with every single drop. So the difference in the volume of the drop would be not so exact. So one drop of water might not have been the same as one drop of acetone. So that is the IMF lab.